In today's lesson, we will be learning about recursion, which in Java is when a method calls itself within the method itself. Recursion is useful to us because it's a repetitive process, similar to how a while loop or for loop is. An example of a recursive process that we're all accustomed to is the factorial. Let's take the factorial of 5 for example. We're taking 5, multiplying it by its decrement, taking that product and multiplying that by the decrement's decrement, and doing that repeatedly until we reach 1. So we're doing 5 times 4 times 3 times 2 times 1, which is 120. And essentially, we're doing a process until a certain case, which is the number equaling 1, is reached. Let's make a factorial method to see how a recursive function should look like. So let's translate the statement multiply this number by its decrement into Java code. That's simple enough. We can just write, I have the function already written here, but let's write num times equal num minus 1. So we've essentially written that. Num will now be equal to num times its decrement, num minus 1. We have the core function down, but how can we do this repeatedly? We're going to use recursion. So let's rewrite this a bit differently. Return num times factorial of the decrement of 1. Let's talk about how this statement works. We're saying return num times the factorial of its decrement. So when the statement is executed, it's not completely executed until this function is executed as well. So now we're doing factorial 5 minus 1, which is 4. So now once our compiler reaches this part of the statement, it runs the entire function over again, but with our input being 4 now. So once it reaches this part of the function, both with the input being 4, now once we reach this part of the function again, num minus 1 will be 4 minus 1, 3. And it keeps doing this infinitely. So we have another part of our core function down, but we don't want this happening infinitely. We need to tell our function to stop when our num equals 1, because that's how factorials work. So we're going to make our case for when our function should stop, and this is called the exit case. So let's write our exit case. If num equals 1, I want you to stop, essentially return 1. This is a good number to return in our exit case because 1 times anything is anything. It doesn't change that value. So 1 is a good value to return here. So this code seems like it could work. So let's test it here. I have our test code ready here. So we're just going to say, hey, do the factorial of 5 using our function and print it out. So let's try compiling it. Oops. Let's take this out. Compile. And run. We should get 120, and lo and behold, we do. We know our function works, but let's delve into a bit more into how it works. So I'm going to just write a little comment section here. And let's go through the process of running this function. So let's say we're inputting 5 as num, right? The first time running this return statement, num is going to be 5, and the rest of the statement will be f of 5 minus 1. That's the first time you're executing the statement. But before we can be done completing this run of the method, we need to complete this function, right? As we stated before. So let's do that. Now f of 5 minus 1, that's essentially performing this return statement again. So now, since the input is 4, we're doing 4 times f of 4 minus 1. And we're doing this repeatedly until we get to our exit case. Oops, sorry there. And then we get 2 times f of 2 minus 1. And thank goodness we made our exit case, or else this would occur infinitely. Now that our input is equal to 1 here, our if statement kicks in and tells our function, hey, return 1, we're done acting recursively, so only 1 is returned. So we've created the sort of stack here of function calls. And now we're going to go back up the stack, completing our function. So let's go back up. So this f of 2 minus 1 is equal to 1. So this is essentially equal to 2 times 1. F of 3 minus 1 is equal to this whole call. So this is pretty much equal to 2 times 1, which is 2. So this is equal to 3 times 2. And we're just going up the stack. So this is equal to 3 times 2, which is 6. So now we're doing 4 times 6. And this is equal to 24, the product of 4 and 6 times 5, which is equal to 120. Now we know how our function really works and how it should look like. So now we know how recursive functions should work. Let me leave you guys with a few general notes on recursive functions. Remember, you should always have an exit case, because if you don't, you will get what's called a stack overflow error, which happens when you're calling a function repeatedly with no exit case, so you essentially just run out of RAM, so your program refuses to work. And going back to my earlier statement on why you might want to use a recursive function rather than a while loop or for loop, recursive functions, in some cases, they can be more efficient than their while loop or for loop counterparts. I recommend trying to write the same function, but using a for loop instead. See how many more lines of code you might need using a for loop. Here, we use 2 lines of code. That's pretty efficient. And if you want to challenge yourself a bit on writing recursive functions, a little challenge I have for you guys is to try to make a function that calculates the sum of a Fibonacci series up to a certain number. And that number would be your input, and you're essentially trying to find the sum of the series until the series reaches that input. So now you guys know what a recursive function is, why it might be useful, and how it should look like, and how to write one. Nice job, guys.